Hey Physics 30, so today we are going to do a lab regarding refraction of a laser within a semicircular dish full of Jello. All right, so we have some Jello in this container here. We got my red laser. Okay, I'm not too concerned about the wavelength of the laser. I've created a chart. You can see here that I have my incident angles all prepared. I'm going to go from 0 to 50 degrees. You're going to see why we're going to stop at 50 in a second, or in a minute or so when we do the lab. And then I got a place to record all my refracted angles. I can see that. We're going to talk about this in a second here, that the incident angles are the angles within the Jello, and the refracted angles are outside in the air. I've created a second table here, as it explains in the lab, that we're going to create a table sine of the incident angles and sine of the refractive angles. It's probably related to Snell's law. Okay. So how this lab is going to work is that I'm going to direct this laser at a certain angle through the Jello, and you can kind of see here the reason that we're using red Jello is so that we can actually see the laser as it goes through the Jello itself. Red and red. If it was green Jello, you'd have to use a green laser. So what we're going to do is we're going to redirect this down along the 0 line. As long as it goes to the center here, there's a center point here. I'm going to be using a piece of paper to determine that. Then we're going to measure the angle as it leaves. As you can see, you can't really see that, but that's what this little piece of paper is going to be used for. I'm going to put this paper down here with a line on it, put the laser on the line, and then I can measure downwards towards which angle it is as it goes through. So you can see that. I can change the angle. As long as I'm pointing towards the center of the circular dish, I should be able to measure both the angles accurately. So I'm going to set up the camera. We're going to get this lab done in just 1 second. All right, so you can see that I've turned off the lights here. I've set up my camera. I got my laser here. You can see my laser at the bottom of the screen there. Hopefully this is nicely focused. I'll move that laser up here. So what we're going to do is we're going to direct the laser through. You can see now, you can see the laser act more a little bit more clearly. So how we're going to measure the angle out on the other side over here is I'm going to use this piece of paper that I have here. It's pretty, not very accurate on your page there, but it's pretty accurate on my page. I'll be able to put the laser down, measure straight down, and be able to measure the angle. So the first step I'm going to do here is I'm going to measure both the angle or laser before and after the refraction. Just 1 second. All right, sorry about that. My lab laser was a little too high. It was refracting off the top, or reflecting off the top of the Jello, but now it seems to work a little bit better. So I'm going to be using this piece of paper here to measure the angle before, and then I'm going to use the paper afterwards to measure the angle here. So I'm just going to do a few of these, and then I'll come back with all the data. I'll show you what the data looks like, but I'll show you a few very specific ones. What happens when you go past a certain point, such as why do we only go to 50 on our angle of incidence here? You can see that the laser is going through the Jello and then exiting out on this side. So the whole point of this calibration step here, and making sure that you're always pointing towards the center of the circular dish, the center right here, is that so it doesn't refract on this edge up here. So whatever angle I measure on the outside, here on the outside, is the angle on the inside as well. Just make sure that there's no refraction here, so that this line is actually going down the normal line of the circular dish. So there should be no refraction at the top here, or the bottom on your picture. And then when it leaves here, I should be able to measure just the refracted angle as it leaves from the Jello into the air. Okay? So you can see what's going to happen is that I move it sideways here. I'm going to point it towards the center. Let's just say I did it at 30 degrees right now. I would just double check to see if it is pointed at the center. And then I would look at what angle it is refracted at. And you can see that here, that is just slightly past 40 degrees. I'm at 30, refracts to 40, so it's bending outwards. Okay, I'll get you some more data here in a second. I just want to show you a few different things, a couple of phenomena that happen here. So one phenomenon that happens is if I go past 48-ish, right? Okay, let me just set this up nicely. Can't really do it with my stand that's here, but if I go past a certain angle, so say right about here, you could see that my angle, it's about 40 degrees going in, comes out about 70 degrees going out. That's not very accurate, so I'm not going to record that data yet. But if I go past a certain point, you could see that there's a beam in here. It gets more and more intense as I go past it. There's always a reflected beam. You can always see something over here. You can see on this side, there's always a reflected beam that comes back out. Remember what I said? Always, if there's refraction, there's always reflection. But this beam is pretty weak right now. It's reflected backwards. But as I go past a certain point, you could see that beam increase in intensity and then it completely internally reflects. So I've passed my critical angle here. Oh, I have to recalibrate that before the experiment starts. But I passed my critical angle here, and then I get this total internal reflection. Okay. As I go through, you could see that it's just a reflected angle. And then after I go back past the critical angle, I get refraction again. So there's something out over here. Okay. Okay, so I've collected my data. If you watched my other video collecting data, then you would see me collecting all this data. So here it is. You got my incident angles. So you may want to pause the video at this point so you can copy down this data. It was at 50 degrees. We didn't get any refraction. If you watched the other video, I tried to get an approximate critical angle. I got it about 48. About 47.5 gave us about 85 degrees, and I was able to get to about 48 degrees. And I was able to get like an outside angle of like 89 or 87 degrees. So it's getting really close to that 90 degrees. So this is just an approximate. In the lab, part of the objectives will be trying to calculate what this is using this data that's up here. How close is it to this approximate that we got? So your goal now is you're going to take all this. You notice I've added some 0.5s to some of these data points because I couldn't quite get exactly 5 and hit the center at the same time. And I got a little bit better down the bottom here. So I got all the 0.0s here as well. So what you're going to do with this data now is you're going to take the sine of these, making sure your calculator is in degree mode because these are all in degrees. You're going to take the sine of these and you're going to put that in this table and take the sine of the refracted angle and put that on this side. And this is the chart that you're going to graph. You're not going to graph this one here. Usually if you have a chart, you have a graph to go with it. But if you have a graph, you have to have a chart to go with that graph. So this is going to be your table here to go with the graph that you're going to create. Yeah, so you're going to graph this. You're going to determine the slope of this line. And hopefully, it's a pretty easy one. The formula makes it a little bit easier. Hopefully the slope is the refractive index of the Jello that you get. It's just one simple formula because the index of refraction of air, which I'll just write right here. If I can write here. We're just going to say the index of refraction of air is 1, right? So our goal is to find the index of refraction of Jello. So you'll get something in the 1.3-ish range when you do this, hopefully. I'll give you a more accepted value in a second here, or in the doobly-doo to the lab. All right? Have fun, enjoy, and get that refractive index. Bye.